morning, everybody. Welcome to our webinar, Predators in Hawaii Wetlands. We still have people joining, so we're just going to give it another minute or so just to let people catch up, and then we'll get started. All right, good morning, everybody. We're going to get going. Welcome to our webinar, Predators in Hawaii Wetlands. I'm just going to start off with some housekeeping. So I'm Helen Rain, the Conservation Specialist for Pacific Birds Habitats Joint Venture. And we also have Lynn Fuller, our Communications Specialist on the line, along with our presenters who I will introduce shortly. All attendees are on mute to avoid any sound problems, and the webinar is being recorded. We'll let you know in a follow-up email where that gets posted. So as our presenters are speaking, you can ask questions at any time in the question box. So you should have a control panel, and you can ask your question as it occurs to you in the question box. And we do encourage you to ask early because there's a slight delay on you typing the question and it showing up. At the end of each presentation, Lynn is going to read the questions out and the presenters will answer. Depending on how many questions we get, we might not get to all of them, but we will answer them after the presentation. We'll talk to the presenters and make sure your questions get answered. At the very end of the presentation, my email address will show up. You can also Google me, Helen Rain at pacificbirds.org, so you can contact me that way. And there is a raise hand button, but it will not help you. So basically, don't bother pressing the raise hand. Just write your question in the question box. And we've got 4 presenters. They're going to be speaking for about 12 minutes each with 3 minutes of questions. And we'll have a little bit of time at the end for any additional questions that you might have if something occurs to you later on. So moving on to our presenters, we've got Jared Underwood from U.S. Fish and Wildlife Service talking about bullfrog trapping techniques. Lindsay Young from Pacific Rim Conservation is talking about predator-proof fences in wetlands and how that's influenced by Hawaii's environment. Maka'ala Ka'aumoana from the Hanalei Watershed Hui is talking about cat predator control on Kauai. And Tyler Bogardis from Greybull Wildlife Services is going to be talking about best management practices for mongoose and rats in wetlands. So thank you very much to our expert presenters for taking the time to join us today. And we're going to move straight on to Jared and bullfrog capture method. All right, take it away, Jarrett.
Okay, welcome everyone. I'm excited to be the first presenter here, and I'll be talking a little bit about improving bullfrog capture methods to benefit specifically Hawaii's endangered endemic water birds. I'd like to acknowledge my co-author on this presentation, Jackson Letchworth. Next slide, please. So the American bullfrog is native to central and eastern United States and southern Canada, but the species has been widely introduced beyond its native range, and that introduction has resulted in devastating consequences for native fauna. Bullfrogs are believed to have arrived in the Hawaiian Islands from California in the late 1800s and early 1900s and quickly spread across the main Hawaiian Islands. Bullfrogs in Hawaii are known to consume native fauna and threaten some of Hawaii's most endangered wetland biota. Next slide. Hawaii's endangered endemic water birds are threatened by bullfrogs, and those include the Hawaiian coot, duck, stilt, gallinule, and goose. Specifically, bullfrogs consume newly hatched chicks of these endangered species. And with total species populations of only several thousand, the loss of every individual has the potential to further threaten each species' existence. Next slide. Over the last 20 years, as a result of conservation efforts by many wetland managers here in Hawaii, we've seen populations of endangered endemic water birds either stay stable or slightly increase. Next slide. This is largely due, as I mentioned, to the active management strategy that includes controlling invasive plants in wetlands, managing water levels to mimic natural hydrologic regimes, and control of introduced predators. Next slide. Predator control will include many of the topics. Many of these other predators will be discussed here today, but those include predator control for cats, rats, mongoose, dogs, pigs, barn owls, egrets, predatory fish, and bullfrogs. Next slide. So why do we care about predator control? Well, these cute little guys here are one reason. Next slide. Really, it's about improving reproductive success. This seems to be the most vulnerable time for our endangered endemic water birds, and what we really want is every single one of these newborns to grow up and become a part of the adult population and contribute to the continued recovery for these species. Next slide. So the U.S. Fish and Wildlife Services manages several of the most important wetlands needed to promote the recovery of endangered water birds as part of the National Wildlife Refuge System, and these occur across almost all of the main Hawaiian Islands. At James Campbell National Wildlife Refuge, Hawaii staff have documented bullfrogs as a major predator of newly hatched chicks. The refuge staff conducts a year-round bullfrog trapping program with increased effort during the peak of endangered waterbird breeding in the spring. Although a variety of control techniques are available for bullfrogs, the current refuge control scheme relies on a fish-style funnel trap that you see here, with red flagging as an attractant. Each trap can capture multiple individuals during a single deployment, and though effective at bullfrog capture in this study, we wanted to explore the possibility of improving capture rates by switching the attractant. And we believe the findings of this study would be applicable in Hawaii, but also in other places where bullfrogs are controlled. Next slide. That was 2 slides, actually. You can go back one.
There we go.
We conducted this study at James Campbell National Wildlife Refuge, which you see highlighted here on the north shore of Oahu. In the inset box, you kind of see a darker green. That is the entirety of the refuge. And this study was specifically focused on the Ki'i unit of James Campbell, which you see in the light green color. Next slide. Here's a picture of the refuge. Again, just from a satellite photo, you see it's a lot of wetlands throughout the refuge, as well as coastal areas. Next slide. And here is a a zoom in on the Ki'i unit, again, where we conducted this study. So for our study, you can see here there were 10 ponds in the Ki'i unit, which range in size from 1.1 to 3.9 hectares and have a gradient of salinity from fresh to brackish. Fresh, the closer you are to the mountains, and more brackish the closer you get to the ocean. We selected, of these 10 ponds, we selected 6 for our study based on suitability for bullfrogs, and suitability is determined primarily by that water salinity. The highest density of bullfrogs occur in the wetlands with the freshest water. Next slide. So to bullfrogs, in this study we used 15 of those fish-style funnel traps I showed you earlier, and these were placed along the shore, and they have a kind of a particular placement requirement. Generally, they're placed between 2 meters and 1/2 meter from shore, and in a depth of water between 0.3 and 0.2 meters. And this is really so that the funnel of the fish-style trap is between 1/4 and 3/4 of the way submerged in the water. It can't be all the way submerged, and it's better not if it's not all the way dry. All right, next. Go back 2 slides. 3 slides. There we go, that one. Okay. So in order to randomly assign trapping locations, we gridded the shoreline of the ponds, the 6 ponds, in a 10 by 10 meter square overlay. We chose a 10 by 10 meter grid because that corresponds with the maximum area of a male bullfrog territory or zone of defense. And in each trapping session, we selected 2 different ponds so that we would have a universe of about 60 to 100 potential trap grid cells to select from. And from that pool of available grid cells, we randomly selected 15 locations for traps, and then each of those randomly selected locations was randomly assigned one of the treatments. And I'll show you those now. Next slide. So we used the red flagging, which again has been used at James Campbell for a number of years. Next. We use a lifelike bullfrog decoy purchased from Amazon. Next. We use an MP3 player that played bullfrog calls. Next. And a light. Next. And then we had a control which had no attractant. Next. Good, go back one. So we tested only 2 attractants and a control in each phase of the study. All trapping sessions were, during a phase, tested 2 attractants. So during each trapping session, all attractants and control had 5 replicates. That's why we had 15 traps. And traps were continuously deployed in the same location during each trapping session, which was generally 4 nights. And they were checked each morning, and then frogs were captured and sexed and then euthanized. And the MP3 players and lights were turned off and on at dawn and dusk. Next slide. To analyze our results, we used some statistical tools in R, and we compared the success of each attractant with the control and then also to each other. And we evaluated the sex bias of attractants, if any of the attractants were more attractive to a particular sex, and if there was a differential effectiveness across the time of the trapping session. So did we catch more frogs the first day, the second day, third day, fourth day? Next slide. So we conducted this study in November and December of 2013, and then again in November 2015 through March of 2016. And we broke it into, we're breaking this into 2 phases. So in November, December of 2013, we conducted what I would call a pilot study where we used a treatment. The treatments were a control, the red flagging, and a decoy bullfrog. As you can see here, we did not do that many rounds of trapping, and our nights varied. So this was not, so we didn't evaluate this session, that first session, as statistically, but it did inform our second phase, which we used, and we selected, from what we learned, we selected 2 different attractants, the calls and the light. Next slide. So what did we find? Next slide. In our first phase, again, we had 55 trap nights, and we basically found that there was no difference in our effectiveness of the red flagging, the decoy, and the control, which again means having no attractant. Next slide. The second phase consisted of 9 equal length trapping sessions of 4 nights each. So we ended up with 180 trap nights. And we can see here a difference in effectiveness between the call, the light, and the control, with the call being the most effective. Next slide. When we looked at it by week, we found that the call was the most effective in 6 of our trapping weeks, and the light was the most effective in 2 of those trapping weeks. Next slide. When we evaluated catch per day by attractant, we seemed to find a decrease, but that was really only pronounced, next slide, when we looked at the calls. So there was a steady decrease in the traps with calls over time, in the number of captures by day. Next slide. We also okay. Yep. We also looked at the sex, and we found that males were significantly more attracted to the calls than females, and we did not find that true for the light or the control. Next slide.
Jared, you're at time, just to let you know if you want to start to wrap it up. There you go.
See, I'm on top of it. Okay, so conclusions. So we found that playing bullfrog calls was the most effective attractant. However, this attractant's effectiveness appeared to be biased toward males, and its success diminished the longer the trap was in the same location. That may not be surprising. This finding may not be surprising, as we would expect any self-respecting male to respond to an intruder in his area. We found that moving traps might possibly increase effectiveness of the traps, but both the calls and the lights required that we turn them off and on in the morning and day, and other attractants did not require that effort. So that raised the level of effort by 50%, and moving the traps actually would double the effort to trap. And so it's unclear whether or not that would actually be of benefit to change from a red flag or nothing to one of those attractants. And like I said, the red flag is probably just as effective as having no lure, which was the original question. Last slide. So in reality, this study just brought up more questions, and that was, well, how many frogs do we really need to control to have enough of an impact to benefit the native water birds? And are there other methods? We just looked at the fish style trap which have been used, but should we be using netting or gigging or shooting in order to improve effectiveness? Or should we be focusing on a totally different life stage like tadpoles? Next slide. I'd like to thank all those who helped me with this, or us with this project. And next slide. Take some questions now, if I have a minute or two.
Great. We have about 6 or 7 questions, and we'll take a minute or two. Perfect. So the first one is from Hob Osterland, and the question is, for interested landowners who live close to wetlands, how might they obtain the traps? What is the euthanasia method?
We built the traps ourselves. I don't know if you can buy some sort of a standard trap, but we just built them ourselves out of the materials, which I'd be happy to share. I think we even have kind of a diagram of how to do it. And the method of euthanasia varied, but we strive to do a quick a quick kill. That could have been some sort of direct force to the head, or in some cases with shooting to the head, something that would kill them very quick.
Okay, and we have another question from Norma Krebs, which is, do you also have cane toads at your facility? Are they found to be an issue in terms of predation on chicks there?
Yes, there are cane toads. So the way that we found out this was that they were a problem, the bullfrogs were a problem, was maybe now about a decade ago, there was a gentleman who was doing a study on stilt chicks and putting radio transmitters on them, and we ended up locating all of the transmitters, or a lot of the transmitters, inside of bullfrogs. To my knowledge, that they were not inside cane toads, but that's how we realized that they were a problem.
Okay, great. And that's all the time we're going to have for questions. We do have some other questions, but those folks who asked questions and we did not get to them, you will see Jared's email at the end of the presentation, or perhaps have that. So Helen, we're going to move on to the next presentation.
Thank you.
Yes, thank you very much, Jared. We're moving on now to Lindsay Young from Pacific Rim Conservation on predator-proof fences.
Okay, can everybody hear me?
Yep.
I'm assuming so. Okay, well, thank you everyone for joining in today. So I'm going to be talking about some of the redesigns we've done of predator-proof fences in the 9 years that they have been up in Hawaii, and how they've been redesigned to work in wetland environments. Next slide, please. So just to give you a background of what a predator-proof or predator exclusion fence consists of, there's the hood, which is kind of that capping piece that runs along the top. There is the mesh, which is actually on this fence, but as you can see, it looks relatively seamless, and that's the part that keeps animals from going through. There are the posts and then a skirt that is underground. And I just want to point out, most of the photos that I'm going to be showing throughout the slide are of the Honouliuli wetland fence, so that you can see what they look like. So I'm going to go through each of these components and their importance to keeping animals out. So the hood and the mesh are basically the two main components that are going to keep everything pest-proof in an area. And there are two different styles. I know many of you have probably been out to Kaena Point in the 9 years that that fence has been out. And that is sort of the original, what we call excluder style fence. It has a welded mesh of little rectangles. So basically each join between the mesh pieces is welded, and a non-welded hood that's kind of curved down. Since that fence, we've learned from some of the difficulties and some of the good features of that. We've transitioned to a different model, which is called the pest-proof style. And these are named after the companies in New Zealand that developed them. And this is essentially a mini chain link. So if you think of a traditional chain link fence, just scale it down to a tiny size. And it has a welded hood. And that's important because it's more of a continuous design. There are fewer seams. As you can see, the mesh is actually all one piece. So the mesh goes from the hood all the way into the skirt, this is partway through construction. Whereas the fence at Kaena Point actually had a horizontal seam about halfway up. So next slide, please. So as I said previously, the two types of mesh are welded versus woven. The materials that you're going to want to be using if you're in a wetland area are mainly stainless steel. Galvanized is appropriate when you're up at montane areas and you don't have as much rainfall or as much salinity, but for most of our wetland sites, stainless steel is going to be recommended. And for assembly, almost all have a roll that goes from the hood all the way down to the skirt with a horizontal seam. And that we've tried to eliminate. So a lot of the maintenance issues we've had have been with that welded mesh because there's breakage at the seams compared to the chain link, and those horizontal seams can separate. So this is why we're sort of talking about having this continuous piece. Next slide. So the skirt is actually the part that keeps pest animals from digging under. So all of those combinations, if you think of the hood itself, that's for climbing animals. So if they climb up, they can't get through. The height is so that they can't jump over, but the skirt is so they can't dig. And interestingly, there are some animal behavior trials that were done And basically they did an enclosure. They built a reverse fence, put everything inside that both Hawaii and New Zealand had to offer in terms of predators, and watch how they got out. And most animals will only dig about 1 foot out from the skirt before moving down and digging right next to the skirt again. So basically, if you put it out about a foot and just under the ground, you're going to deter the vast majority of pests. But this is also one of the areas that we have the most maintenance issue. And there are a couple ways that you can prevent this. So if you have a lot of erosion from the hood can create a drip edge, which exposes the skirt. So having a continuous piece that's a little bit longer than the hood is actually important, as well as flexibility in that mesh so it doesn't curl up. Basically, if it's visible to predators at the edge, it's not going to be as effective. And making sure that it's pinned down with some dirt or in some cases cement, although not quite as much. Next slide, please. Okay, so on the installations, I said before, it's usually laid out 1 foot from the fence and buried with about 6 inches of dirt just to pin it down. Things get a little bit more tricky when you start to go into the water area, and this is where, I'll talk about some of the issues that we've encountered that are specific to wetland sites. Next slide. So pedestrian gates. In most of these fences, you're going to want to be able to access what's on the inside. And there's 3 different styles that can be used, ranging from, I have them ordered from least secure in terms of the pest entry to the most secure. So on areas where it's close to the public, where you don't have a lot of access, the essentially single door at ground level is the least secure, but sort of the easiest option. If you do have to access the site frequently, but it's not public access, you can do an above ground door. And the reason why it's above the ground and kind of an extra hassle to get in, they've done a lot of trials in New Zealand where if you have a hole at ground level in your fence, it's usually exploited within 90 minutes of that hole being punched through, or in this case of a door being left open. And so if you're coming in and out and there's a chance that someone might just forget to close the door or it's not latched, if your gate is above the ground, you're going to dramatically reduce the chances of an incursion. And moving to the most secure on the right would be a double door system where you essentially have a little containment zone, very similar to aviaries if you've entered them, in a zoo setting, where the second door won't open until the first is closed. Okay, next slide. And then for areas where heavy machinery and all sorts of other things need to get in, there are vehicle gates. This is the vehicle gate at Honouliuli. This is something that you manually open, and it's quite heavy. It's not something you want to do very often, which is why we normally suggest putting a vehicle gate in conjunction with a pedestrian gate. Next slide. And so the final sort of design feature that I want to introduce are culverts. And this is something we have not done a lot of in Hawaii. We've built 6 fences to date, and 2 of them have culverts in them, but that is for intermittent potential water flow. There's not water going at any one time. And this is, in my opinion, the weakest link that we have in this fence system, and one that's going to be the most important for a lot of the wetland sites. And that's because it's the most difficult to secure. So low volume intermittent stream flow is okay. High volume regular flow is challenging, but you can deal with it. And if you look at this picture here, this culvert looks extremely overbuilt relative to the amount of water. And that's because with the way the mesh is, you have to have 4 times the surface area of your maximum area of water flow. So basically these culverts are being built to be 4 times the size of the maximum water flow, and that's so that the resistance of the water going through the mesh doesn't actually damage the mesh and make it pest proof. So it's definitely a consideration when you're thinking about putting these in a wetland area, and in my opinion, it's going to be the biggest challenge. Okay, next slide. So for construction and costs are going to vary depending on materials and terrain, anything from $267 per meter all the way up to about $400 per meter. It just depends on access and materials. Next slide. And for maintenance, the hood drip edge is something that is possible for the skirt that you want to avoid. Expansion of the washers. So these are the things that attach, the hood to the mesh and to the posts. And because Hawaii is such a hot environment in areas where it cools down a lot at night, and then gets warm very dramatically in the day. When the sun comes up, you can literally hear the metal creaking. And so we've tried to kind of mitigate that so it doesn't actually blow out all of the attachments, and just keeping everything clean is the main thing. Next slide. Okay, and now comes the fun, or not fun really, because when we built the fences at James Campbell National Wildlife Refuge in Honouliuli, you know, these were our third and fourth fences. So we kind of had an idea of what we were doing. These are relatively flat sites. We thought we've got a handle on this. And then we experienced a level of corrosion in an area that we had never seen. So basically right where that skirt meets the ground, we were experiencing really rapid corrosion, like within a year where there were full holes in the skirt, and it was only on the skirt and we couldn't figure out what was happening. So we took metal samples of both of those fences and sent them off to G2MT laboratories in Houston, Texas. And they went through and did a bunch of chemical analyses for us of what was happening. Next slide. So you can see, well, this is a scanning electron microscope photograph of the Honouliuli fence. And there were high levels of chlorine and sulfur in both of those fence samples, with much higher levels of sulfur in the Honouliuli fence. And basically what was happening is chlorine was being formed from the marine environment. If you think of salt as being Na and Cl, so sodium and chlorine, those chlorine ions were becoming free. And the sulfur from anaerobic bacteria in the mud, which is going to be, again, in most wetland scenarios, was combining to more or less form an acid that was just eating through this. And the combination of the two really accelerated corrosion. So we knew what the problem was. And the solution, it turns out, was to just stop the exposure of the sulfur and the chlorine to water. And so by coating the area that's going to be in contact with the ground and in contact with any standing water, with a fluorocarbon coating basically on the mesh, you can prevent this. So since then, the Honouliuli fence and the James Campbell fence have been retrofitted at their skirt so that the skirt has this coating on it. Okay, next slide. Okay, so just to review, this is our design, basically an excluder design. You can see the hood is curved. You have that horizontal bracket and the woven mesh. And at that bottom left picture, essentially the hood view, the one thing that we really didn't like about this, you notice there's a nice little tunnel there. That is a lovely little rat highway. So to the point where you could actually put traps in that thing and trap your rats as they were running along in the hood. And so that was one of the main deterrents that we didn't like about that design. Next slide. So the design that's ultimately been used and modified is what's at James Campbell, at Kilauea Point, at Honouliuli, and soon to be a couple other locations, is this seamless design in combination with wooden fence posts. The wooden fence posts allow you to customize where the mesh is put. It also doesn't corrode as quickly, provides more stability, and just makes it a little bit easier to work with. Okay, so on to the fun part of what can these fences do. I've sort of talked about the boring bit. And in short, the results are pretty dramatic. So what I'm showing here are wedge-tailed shearwater numbers at Kaena Point. You can see they started nesting in the early 90s with predator control starting in about 2000 and 2001. Their numbers started to go up, but it wasn't until predators were actually eradicated, or at least the predators of wedge-tailed shearwaters were eradicated, that things really went up dramatically. Basically, they doubled the first year and then doubled again the second year. And that has more or less maintained as the fence goes through various phases where there are predator incursions. Occasionally we get a dip, but overall this is due to increased reproductive success. It is not due to immigration. It's because the birds there are surviving and recruiting and reproducing at a higher rate. And so when I started planning for this talk, I thought, I wish there was data at Honouliuli. I didn't know what it was. And so contacted the refuge staff, and it turned out that Dane Christensen, who is a graduate student of Melissa Price at UH, is just finishing up his master's degree on this actual question. So the data that I'm showing now is courtesy of Dane and Melissa, who've graciously allowed me to present 2 slides on this. But basically they looked at still reproductive success in Honouliuli, comparing it to what was going on at Waiava, both pre and post fence, and then between the 2 wetlands post fence. And there were there are 2 really good news take-home points from this. First, reproductive success is much higher, and I'll talk about that in a minute. But the fascinating thing was they had an increased clutch size. So they went from an average clutch size of 3 to that of 4. So an increase in clutch size by about 33%. And the hypothesis around this is that the perceived depredation risk can invoke a physiological response that causes birds to actually reduce their reproductive output. Basically, when they are scared, they don't reproduce as much. And they think that that's actually what's going on here, that the birds in wetlands can actually sense predators and modify their reproductive output accordingly. Next slide. And so what this actually translated into, so if we look at the kind of colorful graph on the left, you can see that first of all, the fate of all nests, it's much easier to follow them. So at Honouliuli, they either hatched or partial hatched. And if you look at Waiaba, there's abandoned, there's flooded, there's hatch and partial hatch, there's predated, unknown, predated cat, predated rat, and just unknown. So basically there's a whole bunch of different categories of what's going on. But the take home is that more eggs hatch and more eggs hatch per nest at Honouliuli. If you go into the middle of those graph there, so number of eggs hatched per nest, you can see a significant difference in the number of eggs per nest. And then proportion of eggs that hatch in each nest is also much higher. So basically the combination of all of these almost triples the reproductive output, or at least the hatching success of stilts. Now we still need to look at reproductive success, not just hatching success, but so far the results are pretty promising. Next slide. Okay, so, it's great. We all recognize if we remove predators, things are going to do better, but that costs a lot of money. And so what we often do is look at predator control versus fencing. What is a cost benefit analysis? And the example I'm using here is something that we did with Pulama Lanai to look at what was more cost effective, to control predators for Hawaiian petrels in the long term, to build just a cat-proof fence or a full predator fence. And they invest a lot in predator control, as a lot of wetland sites also do. And basically, if we look at the top graph here, in the scenario we run for their site, they expected to produce 17 Hawaiian petrel chicks at the site that we looked at per year with their current predator control methods. If we put in a cat fence only, so basically cats taking out the cat predation factor, but still having rats in there, we almost double that. But if we take into account rats and cats, you can see that the reproductive output, the number of chicks per year in the same site, is dramatically higher. So
you're going to have to sort of speed up toward our, we're at 15 minutes.
Okay, I have one more slide. So basically, full predator fence, you get a biological outcome that is just not possible with predator control alone. And if you look at these graphs, predator fences are expensive in the interim in year one. That graph is much higher, whereas current management is lower, but cumulatively, just doing predator control over, say, a 30-year period is much more expensive. And we look at the break-even point of where that cost of predator control exceeds that of the fence. So basically, you want a fence to last at least to this point to be cost effective. Next slide. Okay, so in summary, predator fences have a high initial investment, but potentially comparable cost over time. And the main thing is it achieves a biological outcome that is just impossible in a predator control scenario. There's all sorts of things that happen that you just don't realize that predation was inhibiting when you remove that pressure. And for plants and animals that are on the verge of extinction, this literally might be the only option to get them into a growth scenario to prevent that extinction. Okay, looks like I'm out of time, so next slide. I'm happy to take any questions, and if I don't have time, you're welcome to email me them.
Thank you so much, Lindsay. I think we don't have any questions at the minute, but if any occur to people, they can contact Lindsay or myself afterwards. Our next speaker is Maka'ala Kaumoana from the Hanalei Watershed Hui.
Good morning. Aloha, my name is Maka'ala Kaumoana. My name, as do all names in Hawaii, has a meaning. It means watchful or vigilant. It is a kuleana name, a name given with an assignment, a responsibility. I live on Kauai and it has a kuleana also. It's the oldest currently inhabited high island and the only one without a large population of mongoose in this archipelago. Kauai is home to the U.S. Fish and Wildlife National Wildlife Refuge Kauai Complex, whose mission is to provide habitat for the threatened and endangered water and seabirds of Hawaii. In ancient times, it is said the return of the seabirds from the ocean darkened the sky, and the guano fertilized the lo'i island-wide. This Hawaiian stilt is one of 2,000 left on Earth. Next slide, please. These are the Hawaiian Islands, all of them. In this graphic, you can see how much of each island is above the surface of the sea. For many birds, especially seabirds, Kauai is the nearest safe place to migrate when their atoll is submerged. Next, please. As the nearest high island to those in jeopardy from, oh, nope, you skipped, back. There should be, okay, got that one. Okay, go ahead, you're right. That's fine. This is the picture of the habitat lost on Eastern Island in Midway. Thank you, Beth Flint, for the photo. This dramatically depicts the loss of that habitat. Next slide, please. As the nearest high island to those in jeopardy from sea level rise, Kauai offers habitat to native seabirds and water birds seeking a safe home, a Noah's Ark. Kauai also has people who care, connected to the land as farmers, fishermen, residents, and visitors all feel the pull of responsibility to provide safe habitat for critters calling for help. For nearly 2 decades, a Kauai group representing cultural practitioners was joined by the American Bird Conservancy, the Conservation Council for Hawaii, and the Center for Biological Diversity in legal action against the County of Kauai, the Kauai Island Utility Cooperative, and the Princeville Hotel for take of endangered seabirds on Kauai. Represented by Earth Justice, these groups have led mitigation efforts to reduce the annual losses from human impacts on Kauai. Next, please. The Hanalei Wildlife Refuge is one of 3 U.S. Fish and Wildlife refuges on Kauai. The Hanalei Basin is one of the most important wildlife sites in Hawaii, hosting most of the world population of endangered Hawaiian duck, the Hawaiian common gallinule, and the stilt. These birds have tiny global populations of between 1,000 and 2,000 birds. With such low numbers, every individual matters. Yet in a 4-year period, 2014 to 2018, over 250 native water birds were killed by feral cats, including around 100 Hawaiian gallinules and 40 koloa ducks. That is a major crisis for any endangered bird species. Hanalei is also a flyway for the endangered a'o, Newell's shearwater, and the ua'u, Hawaiian petrel, with hundreds of birds passing overhead to breed within Hanalei Valley. Every year, some birds are downed by light attraction or power line collisions, and once on the ground, they are extremely vulnerable to depredation. Next, please. The Hawaiian goose, the nene, was rescued from the brink of extinction, restarted in Hanalei, and now flourishes there. Flightless when rearing its young and unable to escape its only enemy, the cat. Next, please. 251 of 390 bird carcasses found on the Hanalei National Wildlife Refuge over this 4-year period were identified as cat kills versus barn owl or not distinguishable. Most of these killing cats are actually fed by people in an area just uphill from the refuge. They hunt and kill when full of food. Next, please. Of the 251 documented cat-killed birds, 100 were gallinule, 50 were coots, 40 were ducks, 20 were stilts. Note again that the documented number is significantly lower than the true mortality. The estimated total population count for all 4 of these federal listed species is between 2,000 and 3,000. 222 cats were caught on the Hanalei Refuge over the 4-year period. 5 of those cats were notch-eared and microchipped. The notch ear marks a cat that has been trapped, spayed, or neutered, and returned to the land. This is done by members of the public who think they are doing a good deed and is facilitated by the Kauai Humane Society. Funded by the cat food industry, which happens to also be one of the largest consumers of our world's fish, this effort is the single worst cause of predation and the spread of toxoplasmosis, which is killing the critically endangered Hawaiian monk seal and dolphin. Next, please. As seen here, even very large seabirds, such as the Laysan albatross, that are completely unaware of the threat as they evolved without predators, are victims of these cats. Several Kauai landowners are trying to help by fencing their properties and partnering with local individuals and agencies to remove feral cats. The Kauai Albatross Network has led an effort to provide funding and facilitate projects to install fencing, cameras, and traps to provide safe haven for these amazing birds. Next, please. The Kauai Humane Society is charged with animal control by state statute and county code. Additionally, county code prohibits them from engaging in trap, neuter, release. They get around this by claiming the feral cats are owned by whomever traps them and brings them in. They are then returned to these owners for release back onto the landscape where they continue to kill the native birds. Cats are killed by dogs and cars every day on Kauai. Currently, the Kauai Humane Society is refusing to provide euthanasia to feral cats, causing more cats and birds to die. If you trap a cat on your property and take it to the Kauai Humane Society, they will charge you $95 to euthanize it because they are requiring that it be spayed or neutered and vaccinated prior to euthanasia. Obviously, this has halted private citizen support for trapping. Next, please. The county of Kauai has control over many lands that include habitat for water and seabirds. Although they do have an ordinance preventing animals from being brought into these places, hundreds of feral cats are fed daily in these areas with no enforcement. Just agreed to, the Kauai Island Habitat Conservation Plan includes the control of predators, and as a signer of this plan, the hope is the county will fulfill this obligation by beginning predator control in its coastal parklands. This is not likely to occur without conflict, and the hope is that those who wish to feed feral cats will complete construction of an enclosed sanctuary that will provide a safer place away from protected species. This is an emotionally charged issue for a small island, and factions are dramatically divided. Next slide, please. The Kauai's people have always taken their kuleana seriously and have formed the Kauai Wildlife Coalition to provide education and support for the protection of all creatures who are seeking a Noah's Ark. Mahalo to Ab Osterland for several of these photos and for the leadership of the Kauai Albatross Network, a key partner in the Kauai Wildlife Coalition. This is hard work with many competing interests, and Kauai stands ready for the task. Mahalo. Questions?
At this
Thank
time,
you,
we don't
Maka'ala. Do we have any questions, Lynn?
I don't have any questions at this time. I am going to make a quick reminder here that there is a slight delay with questions. So if you do have a question, try to type it in while you think of it. But at this time, I don't see any questions. And if other ones crop up, we can try at the end of the presentation.
All right. Thanks again. And we move on to our last speaker, Tyler Bogatis of Greybull Wildlife Services.
Thanks, Ellen, and welcome all. Yeah, as she said, I am Tyler Bogatis, and I'd like to recognize my partner, Dominic Souza. Today I'll be mostly talking about best management practices and for mongooses. I do have some rats in there and a little bit of cats for you. Next slide. So I'll be talking about a couple of the sites that I did some trials at, trap placement and grid setup, what those look like, kind of the different trap types and what we looked at years ago and kind of figured out what traps we wanted to use going forward. These alternates, live cages and A24s, the percent activity monitoring with tracking tunnels. So we do have some good information on that, and just overall recommendations and thoughts. Next slide. So I have 3 sites here. 2 are wetland sites, and 1 is what I call an upland site. They're somewhat large. They're all on Oahu on the North Shore. We're primarily doing mongoose, cats, rats, and pigs at these sites. The North Shore Oahu wetlands, about 65 hectares. We have about 1 dock per hectare there. It's about 50 right now, and 100 A24s. At Kahuku Point, we have a pretty extensive network of 75 Dock 250 traps. And don't worry, I'll explain what a Dock 250 here is in a minute. And at the upland site, we have about 70 docks, and then we have some of these lethal cat traps. Next slide. So here's a map showing the Kahuku Point site. It's up at Turtle Bay, for those who can't tell. It's a wetland site, and it also has some coastal area where there are some seabirds nesting. All the orange dots are Dock 250 traps spaced about 100 meters apart on lines that are roughly 500 meters. Yeah, next slide. So back in about 2014, we did some trap trials. There's not too many Dock 250s in the state, and we wanted to know what kind of trap we wanted to use for mongoose going forward. So we trialed Dock 250s versus what you would hear is called a conibear trap or a body grip trap, and we used the size 120, which is the size appropriate for mongoose. We spaced them every 100 meters, and we alternated between the 2 trap types. We also had a bunch of A24s in there. We did this for a 1-month trap out period with weekly checks. And we had an interior trails and a perimeter trail around this site. Yeah, about 1 trap per hectare. So next slide. These are what the Dock 250 boxes look like. It's a metal trap from New Zealand. The DOC stands for Department of Conservation. They actually developed this trap. They do have 3 sizes. The 250 is the largest size. They do have smaller ones that would work for rats. But for us, the 250 is what we need for mongoose here. We make these wooden boxes out of 3/4 inch ply form plywood. There's also a multitude of treated plywoods that you could use. And then we do have these hardware cloth, basically wire baffles, and they are the non-target excluding devices. And so they will exclude waterbirds, dogs, cats. However, anything as small as a mongoose will get in the hole. So if a cat's as small as a mongoose, it'll also get in there. Next slide. And this is what the plywood boxes look like. And I will have a couple pictures of mongoose and traps for this coming up. So just FYI. Next slide. So here's the trial. So we did this for a month, and we caught 283 mongoose in the dock traps, 131 in those body grips, those Connie traps. You can see the no catch, that's amount of traps that trap nights that didn't have catches. And so we ended up with a total of 414 mongooses captured in the 1 month. And it was a significant amount more in dock traps. Next slide. So then we wanted to say, okay, well, the dock uses this pan trigger, and generally, which is a trigger like on the left, but that's a body grip. And then the picture on the right is another body grip with a whisker trigger. And that's generally how those traps come. So we wanted to know, are pan triggers better than the normal whiskers? Next slide. So both traps worked. You can see the pan on the left and the trigger on the right. Next slide. But the pans caught significantly more than the triggers, 84 catches versus 47 in that 1 month period, and equaling the 131 that the body grips caught. Next slide. So we had a lot of A24s in there, and so we were wondering, you know, are A24s also working? It's hard. We don't have counters on them all. Can you advance, Helen? So there's 3 mongoose you can see under an A24. So the A24s definitely do have enough punch to kill mongoose as well. Next slide. And these are some skulls I recovered showing where the striker had hit the mongoose skull. And so they were, you know, lethal enough to deliver a blow that would crack the skull. Next slide. So here's some information from that first wetland site. And this is catches by week. So you can kind of see in that first week, we captured over 160 mongoose in 50 traps, 50 or so traps. And then as you continue on, you start to stabilize and kind of get to this very low level of catch. Next slide. And what's nice is that actually ties right in with the tracking tunnels. And so at the beginning of that trial, we had over 90% activity at that site with mongoose. And then it follows the amount of catches perfectly through time. This only goes up to 2015. I do have information up to 2000, up to today, basically. And we've been at 10% since. So that graph would just continue on that line. Next slide. So here's another site. This is kind of another way to look at it too. This is percent mongoose per trap. So we've got about 550 mongoose at this site in 9 months. And this is at the upland site. I did want to add the upland site in here because we're seeing the same results at this site as we have our other 2 sites that are wetland sites. And so I think for, at least on Oahu, mongoose control, I think is going to be the same regardless of what type of system you're in. We were catching, when you put out these traps the first time, you pretty much however many traps you have, you're going to catch that many mongoose basically. And then as you go on, you can see we're about 9 months post now, and we're still in that kind of 15 to 30% of the traps are being filled with mongoose every 2 weeks. And I expect that number to kind of continue to go down until we kind of level out at probably about 10% of your traps are going to be catching every 2 weeks. Next slide. Here's a little bit of rat stuff. I kind of mentioned it earlier about the A24s and how we set them up. Here's our tracking tunnel results for one of the wetland sites. And we were having a hard time in 2014-15 controlling them. I think that was due to some bait issues with the A24s and some of the malfunctions we were happening. Now we're on 6-month checks with a new type of bait that they make with the automatic lure pumps, and we have been having very good control at this site. Next slide. So, I kind of throw out this term BMP, best management practice, that comes from New Zealand. And I'm not here to actually write a BMP or be the only one who has this BMP. I think we all need to work together to create these. But I think this is kind of a first stab at it. And this is kind of what I've seen and what I would do. I actually have a typo in here. It's actually about a half a trap to 1 trap per hectare is what I'm finding is best for mongoose. That's on a 100 by 50 meter spacing. It seems with the 3 sites we've done work at, we can use existing roads and terrain. We don't have to have this perfectly gridded out square. Ideally a 500 meter buffer from the resource being protected. However, even with the lines that are on the perimeter, with the resources that are on the perimeter of our lines, we have had very good success. We're at a 2-week checking interval, and it seems that you need to do that for about a year. And then after that, it's possible we could go to monthly checks, which decreases your labor costs substantially. That's what's nice about these lethal traps, is that you can really start stretching these out. As long as we can get this bait persistence, the current bait we use is, only about 2 weeks, but I'd say that with some development of better baits, we could easily get to a month or even longer and still maintain a low capture rate. Next slide. So for the rats, I've given a lot of other presentations at other places about this. I will briefly touch on it. The 50 by 100 is directly from New Zealand, and that seems also to work here, especially in wetlands. We are on the 6-month checking interval, and we're using those automatic lure pumps with a slug deterrent lure. I haven't had too much of an issue on the wetlands here on Oahu with the slugs, but up in the mountains, that is a huge concern of ours. Next slide. So yeah, my recommendations, I guess, and overall thoughts, and I'd love to talk to people about it. Dock 250s are the trap that we're using. We have over 300 of them now at the various sites. Traps with pans, from those trials were definitely better than the trigger. So would this hold true for other species? I know other people are using conibear traps for other species like cats. Are pans, gonna give you more catches? The A24s do work for mongoose. I think we need to develop a bait that's more attractive. I think the peanut lure that they used to have was more attractive than the chocolate lure now to mongoose. So I think some development needs to happen on that. And for us, it's just about finding kind of what's that baseline capture rate that we're going to be achieving. I did want to add a little side note that very little mongoose have been observed at some of the sites. So before trapping, so people are like, oh, it doesn't seem like a big problem here. And we've been at the site and you don't really see them, but then you still catch them. So even though we do usually associate them with a species that we can actually see pretty easily, it doesn't mean that you don't have them there. I think that's it. Next slide. Oh yeah, so what I wanted to add this real quick, and if anybody wants to email me, they can. I started to work with these lethal cat traps in the last year or two. These are all from New Zealand. They've passed the humane standards for euthanasia according to their guidelines over there. We're checking these on a 2-week interval, and we're doing about a 200 by 1,000 meter spacing. Next slide. Yeah. With that, any questions?
We do have some questions. The first one is from Aaron Work, and the question is, do you change, I'm sorry if you already addressed this, so it may be an already answered question, but it is, do you change baits, lures, and what is your most effective bait lure?
Yeah, we do a little bit of experimenting with baits and lures, but we generally keep it the same. Our standard is a dry cat food with a couple different trapping oils that you can get from some major trapping sites, shellfish oil and fish oil. That's our kind of go-to for the traps that require a pole bait, like the Tim's, that yellow cat trap. We've used Redondo hot dogs, and dried fish is actually working pretty well.
Thank you. We have another question from Dane Christensen, which is, can you speak on the best bait to use with the A24S?
Yeah, for us, the A24s, the automatic lure pumps that they're making, Good Nature only makes one bait in that. It's a chocolate rat lure, and that is our go-to. And at this time, that's kind of the best bait for the A24s.
Okay, we have time for a few more for you, Tyler, from Craig Gorsuch. Have A18 traps been approved for use? How effective are they for trapping mongoose compared to the A24S?
Yeah, as far as I know, I think we need to contact Good Nature a little more. Those have not been approved, I don't think. They're not here. They're not available yet. So, and their effectiveness, I mean, assuming they work, they're a bigger trap and they've got more punch, so they're gonna get more mongoose. That's kind of the problem with the A24. It wouldn't pass the humane standards for mongoose, but it does get them.
Okay, and next question is from Ty Spangler. What kind of bait do you use in the DOC traps?
Yeah, so the dock traps is the cat food and fish oil in a mason jar.
Okay, 1 second here, as they're still coming in. From Ty Spangler, what kind of bait do you use in the DOC traps? Yes, we had that one.
Yeah, I just answered that one.
Yep, sorry. Lots of moving targets here. From Norma Krebs, do your lethal cat traps meet US euthanasia standards, and what is the price per trap?
Yeah, send me an email. I'd be interested in what those US standards are. To my knowledge, I'm not really familiar with too many of those. I mean, I know there's the AVMA standards. They don't specifically talk about these traps. In New Zealand, I mean, I think the US would be good to adopt their standards because I think they're a better indicator of how well a trap is humane. And so they do meet the humane trials in New Zealand. So I think they would be great to do here. And price, I don't know, they're about 50. I think we can get them for about 50 to 100 bucks a trap with shipping.
Okay, great. We don't have time for additional questions for Tyler right now, but Helen, would you like to do a quick wrap up and then invite folks to stay on for questions we did not have time for?
Yes, so thank you so much to all our presenters. I know they put a lot of time and effort, especially in doing this virtually, so that was much appreciated. I hope all of the attendees found it useful. We have our website up there if you want to find out about more about Pacific birds and to subscribe to our mailing list. And you can get in touch directly with me if you want to talk about how we can partner to increase wetland acreage. Yes, and then other than that, I understand people may have to leave, but we did have a few more questions. We can just spend 5 minutes covering any that we didn't get to before, and beyond that, as I said, we will email out any answers. So I do have a question here for Jared. The question is, how did the moon phase impact your trapping success, if it did, with your bullfrogs? Did we lose Jared? Sounds like we did. Okay, Lynn, do you have any more questions for anybody else?
We have a question from Maka'ala. I need to just go back and find it briefly.
That was my question, Lynn, thanks.
Okay.
And I believe Jared has left.
Yeah, okay.
Okay. All right. Well, I think in that case, we will wrap up. Thanks again to the presenters. And yes, you're welcome to get in touch and enjoy the rest of your day, everybody.
Thanks, Helen.
Thank you. Bye-bye, everybody.
Mahalo, Lynn. Mahalo, Helen.
Mahalo to you.